Here's a problem involving two-dimensional displacement. Now allow me to mess this up and make some big mistakes. A car travels for 63 seconds at 25 meters per second at an angle of 36 degrees north of west. So let me draw, and again, I'm making a mistake right now. There's 36 degrees north of west. The hypotenuse is 25 meters per second. Then the car travels at this 18 meters per second with that direction. Okay, so 28 degrees, and it's 18 is the hypotenuse. 28 degrees. See if you can spot my mistake. For 77 seconds. Delta T2. Find the magnitude and direction of the resultant displacement. That's delta R total. Theta equals. And here is my work. Again, what's my mistake? Delta Y1, this is negative, right? 25 times sine 36. Here, delta X2, what is my mistake? I've already made it now. Twice, I'm about to make it 2 more times. 18 times cosine 28, and 18 times sine 28. And then I would go add this, make it negative, add that with this, make it positive, add this with this. They're both pointing upward or northward, so positive. And then I do the Pythagorean theorem. Okay, what have I done wrong? I missed a crucial step. Look at my triangle. I've labeled this delta x. That's displacement. But my hypotenuse is velocity. This is incorrect. The components of a velocity are Vx, Vy, not delta x, delta y. If I want delta x and delta y as the components, I need to take this two-dimensional velocity and turn it into some sort of displacement. Same thing here. This is not the correct hypotenuse. I need to change that 18 meters per second into a displacement. And now, of course, my hypotenuse won't be 25 and 18. It'll be something else. So let me go ahead and erase the 25. I need to fix it. That was my mistake. Erase the 18. How do I find delta R1? Well, what is this 25 meters per second? It is in meters per second, which means it has to be V2D, a two-dimensional displacement, velocity rather. This is a velocity, not displacement, and I know it's velocity because it's in meters per second. I know delta t, I know the velocity. Well, hang on, I have an equation that says 2d velocity is 2d displacement over time. So I can go plug in, well, let's see, how do I find displacement, delta r? We cross multiply. So this first delta r is simply the first velocity multiplied by the first time. So again, what's my first value of velocity? It's 25. How long am I traveling? 63 seconds. And now I have something that I can put as the hypotenuse. Show this work, 1575. That's the true hypotenuse, and that's what I put into my equation. 1575 times sine and 1575 cosine. I do make this first guy negative because it points to the west. Okay, and over here, what do I need? The same equation. This is a delta r. So let me find the second delta r. Again, I cross multiply from this equation. The way we find delta r is by multiplying velocity times time. So what is the second velocity? 18, that's velocity. I know it's velocity because it's in meters per second. So I've got 18. How long is it traveling at that velocity? 77 seconds. And when I calculate, 1386. That's the actual hypotenuse that I need. My hypotenuse needs to be in meters, not meters per second. My hypotenuse needs to be a delta r, not a velocity. Okay? So 1386 goes here, and 1386 goes here. And from this stage, we simply tally up all of the delta x's. Right, there are 2 that we have to add. So you add those 2 things in, you find your answer. You tally the delta y's, add all the delta y's up. For that, again, there are only 2 delta y's that we have to consider. And we wrote them down, of course. We wrote them all down above, right here. Here's the delta y, here's the other delta y. The delta x's are these guys, so add them up. And once you've got that, I'm not going to go through all the steps because we've practiced it plenty already. You draw the total delta x and the total delta y, and then you use your right triangle geometry to find the total delta r and the angle theta. Okay, you're going to have some practice. You have to use this method. It's the exact same as what we've already done. The only difference is first we need this step where we multiply the given velocity by the given time to find the true hypotenuse that helps us solve the problem. Thanks for watching.